We're going to be looking at another redox reaction with an oxidation and a reduction reaction taking place. And it's a demonstration here. And what I have is I have this blue copper sulfate, and we're going to be primarily concerned with what happens to the copper in this. I also have a strip of zinc. So here's the zinc. The zinc is neutral. The copper actually is not pure raw copper. It's actually copper sulfate, which means that it's dissolved or aqueous inside of the solution, meaning that this is in an ionic form. So I have an ionic form of copper in this liquid, which is making it appear blue, and I have this metallic zinc. So if I put the zinc into the copper sulfate, it's going in nice and silvery, and just with the contact for a few seconds, we see that we have this chemical reaction taking place. So it looks like it's turning into this black stuff. It looks like it's rusting. It's doing it very, very quickly. We're having a very, very fast reaction. So we're going to let this just sit in there, and we'll come back to that a little bit later. So what's happening in this? Which is the pitcher? Which is the catcher? So let's take a look at the zinc. The zinc is going from this state right here, and it's becoming the zinc sulfate over here. The copper is starting off here, and it's ending up in a solid form over here. So the zinc is starting off as being neutral, and it's going to become charged. In this case, the zinc is going to become 2+. So it's starting off with the 0 charge because it's neutral and it's in a solid form. It becomes aqueous, and so the zinc is going to end up with a 2+ charge. Well, how does something go from a 0 to a 2+? It is going to be losing 2 electrons. So in this case, the oxidation reaction, the pitcher is going to be the zinc again. So the oxidation reaction, we have the zinc, and it is in its neutral form, and we'll say that it's in the solid form. And it's becoming zinc sulfate. So we're going to draw this arrow. The sulfate really is not involved with the electron transfer, so we're not going to record that in this part of the reaction. So the zinc becomes charged, and it's a metal ion, so it's going to become positively charged, and it's going to become a 2+. And aqueous means that it's dissolved. So right now, the zinc, which is the metal, is dissolving. And it's becoming aqueous. But it's also, since this is the pitcher, it's losing the 2 electrons. These 2 electrons are going to get picked up immediately, okay, by the copper. So the copper is just sitting there inside this blue fluid. So along come these 2 electrons, and it's sitting next to the copper. Let's find out what's the charge of the copper. Sulfate is a 2-, therefore copper is a 2+ charge. It's going from a 2+ charge to a 0 charge. So the copper is just sitting there in the fluid. Here's the copper, the Cu. It has a charge of 2+. Along come these 2 electrons. These 2 electrons bind onto the copper because the copper has the capacity to absorb those 2 electrons, and we're going to form the copper back again. So here's the copper, and this is going to be forming solid copper, and it's going to be neutral. So if you take a look at this, we're creating this reddish material on the surface, and that's our copper. And what's happening to the zinc? The zinc is actually dissolving, and it's going into this blue fluid here. So again, this is the pitcher in this reaction, and this is the catcher in this reaction. And if we look at the final outcome of all of this, we're going to write these reactions. We have the zinc. We're going to record everything on this side of these two arrows. It's sort of like adding two equations. We're going to add everything on the left-hand side. We're going to add everything on the right-hand side. So here we have the zinc, and this is going to be the solid zinc. We also have the 2 electrons, and we have the copper ion that's sitting there. Here's the arrow. And then we have the zinc with a 2+ charge, plus the 2 electrons. And we have the solid copper. So just like an algebraic equation, we have the same thing on both sides that can be canceled, and those can be canceled. And this is giving us a net reaction from these two smaller reactions. If you remember from the first part of the lecture, what's happening is we have 2 reactions that are taking place. Here's an oxidation reaction, and here's the reduction reaction. It's taking place simultaneously, meaning at the same time. So what we get is we have this reaction that's taking place at the same time. It's this transfer of the electrons from the zinc to the copper. And if you notice, just like an algebraic equation, these are going to cancel. So what's happening is we're starting off with elemental metal zinc and a copper ion, and we get a zinc ion, and we end up with copper metal. So think of reduction. Think of the concept of reduction. Reduction means reduce. Reduction is getting smaller. So I had a difficult time remembering what's the difference between an oxidation versus a reduction reaction. Well, if you think of reduction being reduced, getting smaller, okay, in a reduction reaction, what's happening? This is the catcher. It's getting the electrons. It's becoming more negative. And so in becoming more negative, if you're on a number line, for example, here's a number line, here's your 0, here's your positives, here's your negative. Well, if you're becoming more negative, you're getting smaller. So if you could think about that of reduction meaning smaller, meaning that you're gaining the electrons, you're getting more electrons, becoming more negative. And that's what's happening. The copper is sitting there as an ion, and it gains the 2 electrons. It's positive, and it's gaining the electrons. It's becoming more negative and becomes neutral. Last reaction we've seen before, and this is the metal spheres that I've displayed for you. You can take this aluminum sphere and another sphere with iron oxide, and you crash them together, and it produces these sparks. So what we're going to be looking at is we're going to be saying what's happening to the aluminum and what's happening to the iron. We have 2 reactions that are taking place in this reaction. So the aluminum is starting off being neutral, and again, we can do the reverse crisscross to find the charge of the aluminum, which is going to be a 3+. So it's going from being neutral to a charge of 3+. Same thing with the iron. Using the reverse crisscross method, we can see that this is going to be a charge of 3+, and it's becoming a solid iron as well, a charge of 0. So what's happening is the aluminum is losing the electrons and becoming negative. The iron with a 3+ charge is gaining the electrons to become neutral. So here's the oxidation reaction that's taking place. We're starting off with the aluminum. The aluminum is going to be neutral, and this is going to be some solid aluminum like the sphere that I have. And we're going to this is going to produce the aluminum oxide. And for this reaction, don't have to worry about balancing, but we're going to have 2 aluminums. And the two aluminums are each going to give up their 3 electrons. So if you remember, aluminum oxide has a 3+ charge, keeping that balance there with the aluminums. So we have 2 aluminums here, we have 2 aluminums here. We're going to ignore the oxygens in this case. And we're going to be producing 6 electrons. Each aluminum loses 3, so we get the 6 electrons. The numbers for this aren't important, but it's just to follow the examples of oxidation and reduction reactions. So here we have 6 electrons that are being passed, and what's happening is the iron is sitting there. So this is sitting here, and we have